For the circuit shown below, the resistance values and the inductance values are given. Find the admittance at a resonance. See, if we write the admittance function for this following network, we can write R plus j omega C plus 1 by RL plus j omega L. So at resonance, the imaginary term is going to be 0. That means R plus j omega C plus RL minus j omega L, RL square plus omega square L square. So if we make the imaginary term 0, we will get omega square L square equals to 1 by C minus R square. So omega square L square equals to L by C minus R square. So here now via admittance at resonance equals to R plus RL square plus omega square L square. We can substitute equation 1 in the equation 2, that is L by C minus R square. So if we substitute the given resistance and inductance values, we will get admittance as 1.5 mho. That is option C is correct.
Single phase fully controlled bridge rectifier. Okay, a single phase fully controlled bridge rectifier. That means bridge rectifier consists of 4 thyristors here. It's a single phase fully controlled. Okay, fully controlled in the sense all 4 are thyristors. Okay, input voltage he has given as 230 volts, 50 hertz. Firing angle alpha is equal to 45 degrees. Now what is the DC output voltage of the converter? Okay, this is load. What is the DC output voltage? We know that DC output voltage is 2 Vm by pi cos alpha. Okay, so V naught is equal to 2 into Vm is root 2 into 230 by pi. Cos alpha is cos 45 into 1 by root 2. Okay, we will get V naught as 146.5 volts, which is option B. The average output voltage of a 3-phase half controlled bridge operating with a firing angle of 90 degrees. Now if you see the average output voltage expression, this is 3 root 3 by 2 pi into 1 plus cos alpha. Okay, V peak, or you can write it as 3 root 6 by 2 pi into 1 plus cos alpha V phase. Okay, now 3 root 6 by 2 pi, he has given firing angle at 90 degrees. So this is 1 plus cos 90 into V phase is 400 by root 3. Okay, you will get option as C, which is 270 volts. He has given a 10 volts voltmeter, has a resistance of 100 ohm. Okay, now it is a 10 volt voltmeter, 0 to 10 volts range. It is having a resistance of 100 ohm. Okay, now it is to be converted to 100 volts. The value of series resistance required it. Okay, now let us take, this is 100 volts should be applied. If you want to extend the range of 10 volts voltmeter, we have to connect a series resistance, okay, which is in series with the voltmeter to increase its range. Okay, now what is this one? Vm by Rm, it should be equal to Vsc by Rsc. Okay, now what is Rsc here? Rsc is equal to Vsc times of Rm by Vm. I can write Vsc as V minus Vm into Rm by Vm. Okay, now what is this one? Rm by Vm into V minus Vm, okay, which is equal to V minus Vm is 90 into what is Rm value? Meter resistance is 100 ohms. Now what is Vm voltmeter range is 10. Okay, now what is this one? We have to connect 900 ohms in series to that of voltmeter. So option is C. The no load loss of a transformer at 50 Hz is given as 400 watts, keeping flux density is constant. Okay, Now no load loss is nothing but an iron losses in a transformer, which is equal to summation of hysteresis loss plus eddy current loss. Okay, at Bmax he has given as it is constant. When Bmax is constant, hysteresis loss is directly proportional to F, whereas eddy current loss is directly proportional to F square. Okay, this is a common data question he has given. We have to find hysteresis loss at 50 hertz, and next question is eddy current loss at 100 hertz. Okay, when the no load loss of a transformer at 50 hertz is 400 watts, that means no load loss is equal to iron losses, which is equal to WH plus WE. Since hysteresis loss is directly proportional to F, I can written this as A into F plus eddy current loss is directly proportional to F square. This is B times of F square. And no load loss of a transformer at 100 hertz is 1000 watts. So 1000 is equal to A times of F plus B times of F square. Okay, this is measured at different frequency. Let us take it as F2 and F1. So what is this one? At 50 hertz, so F replaced F with 50 hertz plus B times of 50 square, which is equal to A times of 100 plus B times of 100 square. Okay, now what is this one? This is equal to A plus 50B, which is equal to 8, and this one as, okay, A plus 100B is equal to 10. Two variables, two equations. When you solve this one, A is equal to, you will get it as 6 and B is equal to 0.08. Now look at question 1 there. Calculate the hysteresis loss at 50 hertz. Okay, hysteresis loss is equal to A into F. So this is 6 into 50, 300 watts. So option A is correct. Similarly, eddy current loss at 100 hertz, which is equal to B times of F square. This is 0.04 into 100 square, which is equal to 400 watts. Option D is correct.